Welcome to Java Internals Crashcasts. I'm Sheila, and today we're kicking off our new season on fundamentals of concurrency. We're starting with an introduction to the java.util.concurrent package. Joining me as always is our Java expert, Victor. Hey Victor, are you ready to dive into the world of concurrent programming?
Hello, Sheila. Absolutely. I'm excited to explore this crucial aspect of Java programming with our listeners.
Great. Before we begin, listeners, you'll need a basic understanding of Java and some familiarity with multi-threading concepts. Today, we'll cover the overview and motivation behind java.util.concurrent, the concurrency problems it solves, and introduce some key interfaces and classes. But first, let's start with a quiz question to get our brains warmed up. Victor, what do you think about this one? In a restaurant kitchen, what common scenario best represents the concept of concurrent programming?
That's an intriguing question, Sheila. It really makes you think about how concurrent programming relates to real-world scenarios. I can imagine several possible answers, like chefs working on different dishes simultaneously, or the interaction between the kitchen staff and the waiting staff. It's a great way to visualize concurrency in action.
Exactly, Victor. We'll reveal the answer at the end of the episode, so keep that question in mind, listeners. Now, let's start with the basics. Victor, could you explain what concurrency means in the context of programming?
Certainly, Sheila. In programming, concurrency refers to the ability of different parts of a program to run in overlapping time periods, rather than strictly one after another. It's like multiple cooks working in a kitchen simultaneously, each focused on their own tasks, but collectively preparing a meal.
That's a great analogy. So why is concurrency important in Java programming?
Concurrency is crucial in Java for several reasons. First, it allows us to make better use of modern multi-core processors, improving performance. Second, it enables responsive applications that can handle multiple tasks simultaneously, like a web server responding to multiple client requests. Lastly, it's essential for building scalable systems that can handle increasing workloads efficiently.
I see. So the java.util.concurrent package was introduced to address these needs, right? When was it first introduced, and how has it evolved?
That's correct, Sheila. The java.util.concurrent package was first introduced in Java 5 back in 2004 as part of JSR 166. It was a significant addition to Java's concurrency toolkit, providing higher-level concurrency utilities. Since then, it has evolved with each Java release, with major enhancements in Java 7, 8, and 9, introducing new classes and interfaces to address more complex concurrency scenarios.
Fascinating. Can you give us an overview of the main problems that java.util.concurrent solves?
Absolutely. The package addresses several key challenges in concurrent programming. First, thread safety. It provides thread-safe collections and atomic variables to prevent race conditions. Second, synchronization. It offers advanced locking mechanisms and synchronizers beyond the basic synchronized keyword. Third, task execution. It introduces the executor framework for managing thread pools and asynchronous tasks. Fourth, concurrent collections. It provides high-performance, thread-safe versions of common data structures. And fifth, coordination between threads. It offers utilities like countdown latch and cyclic barrier for complex thread coordination.
That's quite comprehensive. I'm curious, how does concurrency differ from parallelism? I've heard these terms used interchangeably sometimes.
Great question, Sheila. While related, concurrency and parallelism are distinct concepts. Concurrency is about structuring a program to handle multiple tasks that can progress independently. Parallelism, on the other hand, is about simultaneously executing multiple computations, typically to improve performance. A concurrent program may not necessarily run in parallel, but it's designed to handle overlapping operations efficiently.
Thanks for clarifying that, Victor. Now, could you give our listeners a real-world example of where java.util.concurrent might be used?
Certainly. Imagine an e-commerce website handling Black Friday sales. It needs to process multiple user orders simultaneously, update inventory in real time, and send confirmation emails, all while remaining responsive. java.util.concurrent provides tools like executor service for managing these concurrent tasks, concurrent hash map for thread-safe inventory updates, and blocking queue for coordinating order processing.
That's a great example. It really illustrates the practical applications of concurrent programming. Now, I've heard that concurrent programming can be quite challenging. What are some common pitfalls developers should be aware of?
You're right, Sheila. Concurrent programming can be tricky. Some common pitfalls include, first, deadlocks, where two or more threads are unable to proceed because each is waiting for the other to release a resource. Second, race conditions, where the program's behavior depends on the relative timing of events. Third, thread starvation, where a thread is perpetually denied access to shared resources. And fourth, memory inconsistency, where changes made by one thread are not visible to others due to caching effects. The java.util.concurrent package provides tools to help mitigate these issues, but developers still need to be vigilant and follow best practices.
Those sound like significant challenges. Do you have any tips for our listeners on how to approach concurrent programming safely?
Absolutely. Here are a few best practices. First, use high-level concurrency objects from java.util.concurrent when possible, rather than working with threads directly. Second, prefer immutability where feasible, as immutable objects are inherently thread-safe. Third, keep shared mutable state to a minimum. Fourth, use thread confinement when shared state can't be avoided. Fifth, document your concurrency design decisions clearly. And sixth, use testing tools designed for concurrent programs, like stress tests and static analysis tools.
Those are excellent tips, Victor. As we wrap up, let's reveal the answer to our quiz question. The scenario in a restaurant kitchen that best represents concurrent programming is multiple chefs preparing different components of meals simultaneously. Just like in concurrent programming, they're working on separate tasks that contribute to a common goal, coordinating their efforts and sharing resources.
That's a perfect analogy, Sheila. It really captures the essence of concurrent programming.
Indeed it does. To summarize today's episode, we've introduced the concept of concurrency in Java, explored the java.util.concurrent package, its history, and the problems it solves. We've also discussed the differences between concurrency and parallelism, looked at real-world applications, and touched on some common pitfalls and best practices.
Excellent summary, Sheila. In our next episode, we'll dive deeper into the concurrency problems solved by java.util.concurrent and start exploring some of its key interfaces and classes.
Thanks, Victor. Listeners, we hope you found this introduction helpful. If you enjoyed this episode, please subscribe to Java Internal's Crashcasts and leave us a rating. Your support helps us continue creating in-depth, educational content. Until next time, happy coding!